Today I am here with you to discuss the topic of plus 1 class basic concepts of chemistry. Today my learning objectives are chemical formula, empirical formula, molecular formula and how to determine empirical and molecular formula. Okay, let us start. Now what is chemical formula first of all? Dear students, chemical formula is a symbolic representation of any compound. What are the different elements present? Their symbol we will write. For example, for water we write H2O. It means hydrogen is present here, oxygen is present. The symbols are there. Benzene having formula C6H6 like this. Now these chemical formula is of two types. One is known as your empirical formula and another is known as molecular formula. Empirical formula, first of all, what is it? Empirical formula is the primary formula. Means what it informs us, what it tells us. It gives simplest whole number ratio of atoms of various elements present in it. Simplest whole number ratio of atoms of various elements present in it. For example, water having empirical formula H2O and benzene having CH. Means here carbon and hydrogen are present and the ratio between them is 1:1. And in glucose, the empirical formula is CH2O. Means the ratio between the various elements atom is 1:2:1. Right? It is not giving us the value. What actual value of carbon? Is it 7:14:7? That also gives you 1:2:1 and 6:12:6 also giving same. So we don't know actually how many atoms of each element are present here, right? We are only having the information that the ratio is 1:2:1. That can be any number there. So this is your known as empirical formula, which gives only simplest ratio of the atoms of various elements, not actual number. So it is known as empirical formula, but the formula which gives actual number of atom of each element present in the compound, that is known as molecular formula, which generally we are using in our daily reactions. Okay, so it is actual number of atoms of various elements present in one molecule of a compound, that is known as our molecular formula. For example, water is H2O. It means that some of the compounds, not all, some of the compound, their empirical formula as well as molecular formula are same. In case of benzene, we discuss out benzene having molecular formula C6H6. So here it is very much clear that benzene having 6 atom of carbon and 6 atom of hydrogen. But in case of its empirical formula, it was not clear. Ratio was there 1:1. Here 6:6 means 1:1. Ratio of the atoms of the various element is 1:1. But actual number is 6 of both carbon and hydrogen. Same for the glucose. Here now the formula is C6H12O6. So this is the actual number of atoms given by this. So now next is how to calculate the molecular formula and empirical formula. First of all, if in general it is asked to calculate our empirical formula, if molecular formula is known to us, that case take out common factor from the molecular formula. If present, then the next which we will get, that is the empirical formula. For example, in case of glucose, molecular formula is C6H12O6, and common is from here. 6 is the common factor. I got C, after taking out 6 as common, I got CH2O. So this is our empirical formula. We can do this way. In case of water, there is no any common factor. So empirical formula and molecular formula are similar. In case of benzene, empirical formula is CH. Now molecular is C6H6. Yeah. From here common factor is 6. So this is the empirical formula. This way we can calculate it theoretically. But next, which is very important, how to determine the empirical formula and molecular formula if we have given percentage composition. In that case, we are having some step by step we will proceed and we will get our empirical formula and at last molecular formula. Okay, what are the various steps that we will come to understand by solving one numerical sidewise. So what is the numerical? I will correlate both of them so that it becomes easy to digest the concept of this to determine empirical and molecular formula. Alright, let us start. First, empirical formula of any compound. The step, I have the question is here, a compound contains 4.07% of hydrogen, 24.27% of carbon and 71.65% of chlorine. Its molecular mass is given to us 98.696. What is now its empirical and molecular formula? So what are the steps? First step, it says that to calculate empirical formula, first we have to calculate mole of atom. Mole of atom are calculated by the formula percentage of the element divided by the atomic mass. So dear students, what are given here? First we will make a table. In that first of the column we will write element. What are the element present? Write their symbol. Carbon is given here, hydrogen and chlorine are there. What are their percentage composition? For carbon it is 4. For carbon it is 24.27. For hydrogen 4.07. For chlorine 71.65. This we have to done. Then we have to write the atomic masses. Carbon is 12, hydrogen 1, chlorine 35.5. So this is your the way. Now first step you have to write moles of atom. So that is percentage of element divided by atomic mass. Yes. Percentage is this. Divide this percentage by the atomic mass of the for this carbon 12. Answer you got 2.02. And next hydrogen percentage 4.01. Atomic mass 1. Divide that again same we got 4.07. Chlorine percentage is 71.65. Its atomic mass is 35.5. Now divide it and you got the mole of atom 2.02. So this is our we have done. Step 1 is complete up to here. Then second step is divide the result of step 1 by smallest value to get simplest ratio. We have to calculate these values, these moles of atoms in simplest whole number ratio. That is our target, because this number cannot be in fraction. Alright, we will discuss why it is there. So this number is not in fraction. So to make it whole number, there are further modification of these results are there actually. So what it says, how to do this? Very easy. It's saying, first of all, after calculating mole of atom, you have to divide all the values which are there we are obtaining here by the smallest number which the results having given. Right? That is the step 2. Divide result of the step 1 by smallest value or to get simplest ratio. We need simplest whole number ratio. So they have done, we have done here 2.02 is the smallest number here. We will divide with it all the results we have obtained here. So 2.02 divided by the 2.02 we got 1. 4.07 divided by 2.02 got 2, and 2.02 divided by 2.02 again 1. So now we are here mole ratio or atomic ratio, that is simplest ratio. This step number 2 we have done. Okay, now when we will proceed for the step number 3. Now if I will not get my this number, this value, simplest atomic ratio here not in whole number, that case we will proceed for the step number 3. Right? There we have to convert these values. If it is not present in whole number, if it is in fraction, then how to do? We are multiplying with the integer. We are multiplying the values of the second step with the integer, smallest integer. First we will start multiplying with 2. For example, if I am having here 2.5 value, that time I will multiply with the 2 and all the values should be multiplied with 2. I will got the result 2 and it becomes 5 and it becomes 2. Right? If it is not there, it is simple whole ratio, we have to do up to here. Then step 3 we will not follow here in this case. Right? Okay, if your question is there, if after multiplying the 2, sometime the value is not, then we will use whole number, then what we will do? We will multiply with 3. That is according to the situation. But, right? Yes. Here, but the values are already in whole number, then we will follow step number 4. What is there? Now write empirical formula by writing symbol of elements with their numerical values. Okay, so here we are having, first I will write carbon. What is the number we got here? 1. One number, we are not writing any formula. Right? H. What is the value here? 2. Chlorine, Cl symbol. What is the value here? 1. So, this way we have to write the values with the symbols of the element. Now this we got here. This is our empirical formula. So we have determined the empirical formula by the help of the percentage and percentages. So we are following these 4 steps. Alright? Okay. Now this is for the up to here empirical formula. We got empirical formula. Now next, if it is asked how to calculate your molecular formula, so we have to repeat the same step we have done here. Now molecular formula, the actual number of atoms we have to calculate. First step is determine empirical formula we have done. Calculate empirical formula mass. We know how to calculate empirical formula mass, just like how to be calculating molar mass. So here empirical formula mass, carbon having 12 atomic, individual atomic masses of each elements are added. So 12 for carbon, hydrogen atomic mass is 1, 2 atom. For hydrogen, it is 2. 35.5 for the fluorine. So it is 2 here. Alright, you will got 49.5. 2 are hydrogen, fluorine is 35.5, we are getting 49.5. Alright. Then next is calculate molecular mass. Third step is calculate molecular mass with suitable method. Now sometimes molecular mass is given us in various methods, right? Or if vapor density is given, then molecular mass is equal to 2 multiplied by the vapor density. That is according to the data if it is given. Not then simply molecular mass is given to us. So that is we will write like as it is 98.96. Okay. Next is determine value of N. N is an integer and it is equal to molecular mass upon empirical formula mass. Alright. Molecular mass is given to us 98.96 and empirical formula mass we have calculated from the empirical formula, right? So it is 98.96 divided by 99.5. Divide these two, we are getting the value here, n, that is 2. Value of n is 2. Okay, now last step is to molecular formula is equal to n multiplied by empirical formula. Empirical formula is CH2Cl multiplied with the integer 2. And now when we multiply, we will multiply this number of atoms of each element. So carbon becomes 2, hydrogen becomes 4, chlorine 2, and the molecular formula becomes C2H4Cl2. This way, this is our answer. We are able to calculate by following these steps our empirical formula and molecular formula. And this is for the today. And what we have discussed here, what is the chemical formula and molecular formula, empirical formula, how to calculate them. So I think that concept is clear. That's all for today. Thank you.